In previous classes, we completed question number 1 to question number 100, Determinants Objective JEE. In this class, we will do from question number 101 to 115. Okay. You observe this question number 101. They given determinant like this, dk. The determinant they given like this. This is the given determinant. And they given that sigma k equal to 1 to n dk is 56. Then what is the value of n? Okay. You observe in this determinant k related terms present in first column only. Please observe k related terms present in first column only. So when I apply this sigma, it works only for first column. It doesn't work for second column or third column because the sigma is from k is 1 to n. In these two columns, there is no k. Okay. So when I apply sigma k equal to 1 to n 1, suppose for this element, if I write sigma dk, here this whole thing is what? This whole thing is dk. Here what they given? Sigma k equal to 1 to n dk. That means this is sigma 1. What is sigma 1? Sigma 1 means 1 plus like that n times. This is nothing but n. So I written n here. I hope you are understanding. Sigma 1 is n. I hope you got this point. Now you see this one. Sigma 2k. Sigma 2k. K is from 1 to n. That is what? Sigma 2k. In first PUC, we learned the sigma 2k can be written as 2 into sigma k. That is 2 into sigma k is k into k plus 1 divided by 2. Here 2 will get cancelled. You will get k into k plus 1. Here this is 1 to n. This is k equal to 1 to n. Then what you will get? You will get n into n plus 1 divided by 2. Here this is sigma k equal to 1 to n. 2k means in place of 2 you take it outside. 2 sigma k equal to 1 to n k means that is 2 into, in place of k you write 1, in place of next you write 3, like that up to n. Okay, that is 2 into n plus 1 divided by 2. 2 will get cancelled. Again you will get this only. I hope you understand this. And now what is this one? If I apply this sigma 2k minus 1, 2k minus 1, k is 1 to n. In place of k, you write 1 first. Then what you will get? 1 plus, in place of k, you write 2. Then you will get 2 2s are 4, 4 minus 1 is 3. Now in place of k, you write 3. You will get 5. Like this, what you will get? Sum of odd numbers. Last term is 2n minus 1. Sum of odd numbers, we know this is n square. You can calculate this with the help of sum of n terms in arithmetic progression also. So this is n square. Okay. So here what is this? This is nothing but n square. I hope you understand this. These are all as it is because they are no way linked with k. Okay. Equal to 56. I hope you understand this. I just here they given sigma this equal to 56 now. I just calculated this. While calculating this, only first column elements will change. That's what I written here. Remaining all are as it is, equal to 56. Now you see here n is there, here n is there, here n is there, here n is there. What I'll do, I'll make this 0 by using this element. I'll make this 0 by using this element. I'll go with this operation. C2 changes as C2 minus C1. C3 changes as C3 minus C1. N minus n, that is 0. See here, n minus n, that is 0. Okay. Here I multiply these two things, n square plus n. You multiply these two things, 2 will get cancelled, n square plus n you will get. Now C2 minus C1, when I apply this minus this, you will get 1. Okay. C3 minus C1. Here let me complete this. N square minus n square is 0. See, if you apply this operation, this element will become 0. This minus this is 1. This minus this is 0. I hope you understand. Now C3 changes to C3 minus C1. You apply this operation. N minus n 0. N square plus n minus of n square plus n, that is 0. Now this element minus this element, that is n plus 1. You observe here, this is the determinant of a diagonal matrix. What is the determinant of a diagonal matrix? Product of all its diagonal elements. n into 1 into n plus 1, that is n into n plus 1 is 56. Now you can do this n value in two methods. One is verification, another one is if you simplify this you will get a quadratic equation. From that you can find the n value. I'll go with verification method. They are asking n value only. Now if I take n is 4, if I take n is 4 here, 4 into 5, that is 20, but we need 56. So first option is wrong option. I'll take n equal to 6. 6 into 6 plus 1 is 7. 6 7s are 42. Here 56 is there. So this second option also wrong option. You take n equal to 7. Third option, n equal to 7. 7 into 8. 7 into 8 is 56. So here we need 56 only. So 7, third option is the right option. I hope you understand this. Now you observe this question number 103. If n is a positive integer, then the value of this determinant is what? Here we need to find out. Okay. You observe this first row. Here n factorial is there. This can be written as n plus 1 into n factorial. Please try to understand. N plus 1 factorial can be written as n plus 1 into n factorial. N plus 2 factorial can be written as n plus 2 into n plus 1 into n factorial. What I am trying to say, from first row we can take n factorial common. You see here I taken n factorial common from the first row. Then what you will get here? 1 you will get. What you will get here? N plus 1 you will get. What you will get here? N plus 2 into n plus 1. From first row I taken n factorial common, then I got these elements. Similarly, you take n plus 1 factorial common from the second row. N plus 1 factorial common from the second row, then you will get these things. And you take n plus 2 factorial common from the third row, then you will get these things. I hope the things are clear to you. Now you observe all the elements of first column are 1. So what I'll do, I'll make this element 0, this element 0 by using this element. See, R2 changes as R2 minus R1, R3 changes as R3 minus R1. These things I written as it is. When I apply this operation, R2 changes as R2 minus R1, first row is as it is. 1 minus 1, that is 0. This element minus this element is 1. Now this element, little bit of simplification you need to do here. This element minus this element is 2n plus 4. Now R3 changes as R3 minus R1. This element minus this element is 0. This element minus this element is 2. This element minus this element is 2n plus 6. Now here what I am observing, if I can make this element 0, this determinant will become determinant of a diagonal matrix. So R3 changes as R3 minus 2R2. By keeping what I used this operation, I just want to make this element 0. Okay. So here n factorial, n plus 1 factorial, n plus 2 factorial I written as it is. R1 also no change in R1, no change in R2. These things I written from here as it is. R3 change is there. So 0 minus 0, that is written like this. R3, 2 minus 2 into 1, that is 0. I just applied this operation to third row. Okay, then you are getting 2 here. Now you see, this is the determinant of a diagonal matrix. What is the determinant of a diagonal matrix? Product of all its diagonal elements. So here 1 into 2, that is 2 into n factorial into n plus 1 factorial into n plus 2 factorial. I hope you are understanding. See, this type of operations, if I explaining all these things, it takes so much of time. For this determinant, you can easily apply this operation. When you apply this operation to this determinant for the third row, then you will get these elements. It can be understood easily. So this is the answer. You observe the options. Second option is the right option for this. 2 into n factorial into n plus 1 factorial into n plus 2 factorial. That is what we got here, right? Next problem. You see, this is some information is missing actually in the question. If this is delta, see here A1, B1, C1, A2, B2, C2, A3, B3, C3 is delta. They given like this. Capital A1, capital B1, capital C1, capital A2, capital B2, capital C2, capital A3, capital B3, capital C3. What is this? What is this capital A1? Actually, their intention is they are trying to say that this is cofactor of this element. And this is cofactor of this element. And capital C1 is cofactor of this element. Capital A2 is cofactor of this element. I hope you are understanding. So determinant of, what is this cofactors? What is adjoint A? Adjoint A is transpose of cofactor matrix. You know, in determinants, determinant of A is same as determinant of A dash. One of the property in properties of determinants. So here, whatever they are asking, that is determinant of adjoint of this matrix. Please try to understand. We have a formula in synopsis. Determinant of adjoint A. Determinant of adjoint A is det A whole power n minus 1. See, determinant. See, what the main point here? This is same as determinant of adjoint A. Determinant of adjoint A formula is what? Det A whole power n minus 1. What is n here? N is order of the matrix. Here order of the matrix is 3. 3 minus 1 is 2. Right? So here det A whole square. Det A, here actually A means I consider this as a, det A is what here? Det A is nothing but this. This is nothing but they given as delta. So what you will get, this equal to delta square. So what is the right option? Third option is the right option. I hope you understand this. Now observe this question number 107. They given delta equal to 5. Okay. Delta dash is something given here to confuse you. Them written like this. Actually, it is very easy. See, B2C3 minus B3C1. It is the cofactor of A1. See, what is the cofactor of A1? Minus 1 whole power I plus j into minor of this element. That means, see, I'll calculate this. Minus 1 whole power first row first column element into B2C3 minus B3C2. You can look here. Whatever they given here, what we got here, both are same only. Please try to understand. What I am trying to say, if you observe this determinant, this is the cofactor of this. That means what they given here, delta dash, that is nothing but determinant of adjoint A. Adjoint A means this part here. See, last question, previous question, what we discussed, this question very similar. Here, these are all the cofactors of this. So what they are asking, delta dash here, that is determinant of adjoint A. What is determinant of adjoint A? They given here determinant of adjoint A as delta. So here, this is delta. So determinant of adjoint A formula is what? Determinant of adjoint A formula, det A whole power n minus 1. Det A whole power n minus 1. 3 minus 1 is 2. Okay. You observe they given this det is 5. So 5 square is 25. Its answer is 25. I hope you understand this. Now next problem. You see, A equal to cos 4 pi by 3 plus I sin 4 pi by 3. Then what is this value? Okay, cos 4 pi by 3. You know how to calculate cos 4 pi by 3. Cos of pi plus pi by 3. Cos of pi plus pi by 3 is what? Minus cos pi by 3. Pi by 3 means 60 degrees. That is minus 1 by 2. See here, minus 1 by 2. Similarly, you calculate sin of 4 pi by 3. You will get minus root 3 by 2. So, we know in cube roots of unity this point, omega is nothing but minus 1 plus root 3a by 2. Omega square is nothing but minus 1 minus root 3a by 2. Here you see this is minus 1 minus root 3a by 2. What we got here, that is nothing but omega square. So here a is given like this. When I calculate a, I got that a is nothing but omega square. Now in this, in place of a, I'll write omega square. In place of a, I'll write omega square. Okay. If a is omega square, what is a square? A square is omega power 4. Omega power 4 can be written as omega cube into omega. Omega cube value is 1. 1 into omega is omega. Okay. So in this, in place of a, you write omega square. In place of a square, you write omega. Okay. I hope you understand. Now what I'll do, I know 1 plus omega square is 0. So I am going with this operation. C1 changes as C1 plus C2 plus C3. That means all the elements of first column will change. Right? 1 plus 1 plus 1, that is 3. 1 plus omega square plus omega, that is 0. 1 plus omega square is 0. We know 1 plus omega square is 0. Okay. Now I'll expand this determinant. Then you will get 3 into omega minus omega square. Here omega means we know this na. Omega square means we know this na. You just subtract these two. Then you will get root 3i. 3 into root 3i. This is imaginary part or real part? After simplifying this determinant, I got here 3 into root 3i. 3 into root 3i is purely imaginary. So second option is the right option. Now you observe this question number 12. A, B, C are: A is the pth term of geometric progression, B is qth term of geometric progression, C is rth term of geometric progression. Then the determinant of this value is what? That is what they are asking. We know nth term of geometric progression, a into r power n minus 1. To avoid the confusion, here I am taking first term as capital A, common ratio as capital R. What is a? Pth term. That means a is capital A into r power p minus 1. This is the pth term of geometric progression. A is the pth term of geometric progression. That's why small a is taken as a into r power p minus 1. Small b is qth term. That is a into r power q minus 1. Small c is a into r power r minus 1. Now what I will do in this determinant, in place of a, b, c, I will write these values. See here, in place of a, I written a into r power p minus 1. In place of b, I written a into r power q minus 1. In place of c, I written a into r power r minus 1. I hope you are understanding. Here I written few steps directly. Please try to understand. You see, log mn formula, log m plus log n. So this can be written as log a plus logarithm of r power p minus 1. I hope you are understanding. This can be written as log a plus logarithm of r power p minus 1. So here when we know that in a determinant, if a determinant if all the terms are expressed as sum of two terms, then the determinant can be expressed as sum of two determinants. So this can be written as log a plus logarithm of r power p minus 1. So this is log a plus logarithm of r power q minus 1. This is log a plus logarithm of r power q minus 1. So log a like that, and here 1 1 1 is there. If I take log a common, those that first determinant will become 0. Please try to understand, as it is the objective question, we cannot write all the steps. You write this as log a plus logarithm of r power p minus 1. Here log a, and here 1 is there. So first determinant value will become 0. Second determinant is what? Logarithm of r power p minus 1, logarithm of r power q minus 1, logarithm of r power r minus 1. PQR 111. I hope you understand this. In case if you have doubt, you please refer our college material. They written a few steps in detail. Now you observe this one. You know logarithm of a power m is m into log a. Logarithm of a power m is m into log a. This can be written as p minus 1 into log r. This can be written as q minus 1 into log r. This can be written as r minus 1 into log r. See, log r is there. Now log r, if I take common, what I will get? P minus 1, q minus 1, r minus 1. You see here, I will change this second column. C2 changes as C2 minus C3. C2 changes as C2 minus C3. If I write like this, C2 changes as C2 minus C3, P minus 1, Q minus 1, R minus 1. You see, these two columns are identical. So the value of this determinant will become 0. I hope you are understanding. The value of this determinant is 0. Log R into 0 is 0. So for this question, what is the right option? First option is the right option. Now we will move to next question. You see here, L square plus M square plus N square equal to 1. L1 square plus M1 square plus N1 square is 1. L2 square plus M2 square plus N2 square is 1. Some information is given here. All these things are given. Then what they are asking, determinant of this value they are asking. Actually, initially you may not get this idea. Here L1 square, L2 square, like that it is there. Now what I will do, I will square this determinant. See here, I named it as delta here, delta square. I am calculating delta square. I named it as delta. I am calculating delta square. See, delta square is nothing but this determinant into this determinant. 2 times I written. Now you multiply like normal multiplication. You just multiply. We know the determinant of AB is det A into det B. So multiplication of these two, nothing but multiplication of these two determinants. What I will do here, first I will multiply this matrix and this matrix. Multiply first row, first column, L1 square plus M1 square plus N1 square. I hope you are understanding. Now first row, second column, L1, L2, look here, plus m1 m2 plus n1 n2, just normal multiplication only. You multiply these two, then you will get these things. Here you can observe this already given in the question. What is this? This value is 1. You see this value also given. This value is given as 0. See here, in place of this 0 already given in the question. L1 L3 m1 m3 plus n1 n3, this is also given as 0. Like that, all these values are given in the question itself. You substitute those values, what you got? This is the determinant of a diagonal matrix. What is the determinant of a diagonal matrix? Product of all its diagonal elements. This is the determinant of a triangular matrix. Determinant of a triangular matrix is what? Product of all its diagonal elements, 1 into 1 into 1. So what you got? You got that delta square equal to 1. In the question, what they are asking? In this is I taken as delta now. Delta they are asking. If delta square is 1, what is the delta? Delta is plus or minus 1. So which option is the right option? Second option is the right option. I hope you understand this class. Practice makes man perfect. From this question number 101 onwards, whatever the questions are there, they are little difficult compared to first 100 problems. Please try your best and you take the help of our college material.